All right, so here's another motion problem involving the d equals rt. George's boat cruised 45 miles upstream and 45 miles back in a total of 8 hours. The speed of the river is 3 miles per hour. Find the speed of the boat in still water. I'm going to let x be what we're looking for here. So let x be the speed of the boat in still water. Now, before we set up an equation, again, I think it's a good idea to figure out, like in a distance equals rate times time, you have usually a couple scenarios. So for instance, we've got a boat. Some of the trip it's going upstream at a certain rate, and some of the trip it's going downstream at a different rate, right? But we know that the speed of the river is 3 miles per hour. So upstream, that 3 miles per hour is going to be working against the rate, and downstream it'll be working with the rate. Okay, and we want to find out if there was no current, how fast would the boat move, right? So we've got upstream and downstream. And we want to know, we've got some information about distance, rate, and time. Okay, so the distance that he goes upstream and downstream is the same. It's 45 miles. And then the rate upstream, we're going to be going slower, right? So we're going to take the speed of the boat and subtract 3 miles per hour. And then downstream, we're going to take the speed of the boat and add 3 miles per hour, right? Okay. Now, the time, remember, time is equal to the distance divided by the rate. So we're going to have 45 over x minus 3 for the upstream case, and 45 over x plus 3 for the downstream case. Okay, and we know that the total time for the trip is 8 hours, right? So if I take the two times that I have, the expressions for time for the upstream and downstream scenario, and I add them up, so I'll have 45 over x minus 3 plus 45 over x plus 3 equal to 8, right? Okay, so because we're adding up the times and the total trip time is 8 hours. Okay, so I have a little equation that I built, right? So sometimes building that table just to organize the information, it can do wonders to help you build the equation. Okay, so I'm going to multiply both sides by the LCD, which is x plus 3 times x minus 3, right? Know that all of this has to be multiplied to both of those terms, right? In the first term, the x minus 3's cancel, right? So we'll be left with 45 times x plus 3. And in the second term, the x plus 3's are going to cancel, and I'm going to be left with 45 times x minus 3, right? Um, Now, if you need to write that out, write the x plus 3 times x minus 3 in each of the numerators, and then cancel what applies, go for it. All right. And then on the right-hand side here, we've got 8 times x plus 3 times x minus 3. X plus 3 times x minus 3 is x squared minus 9, right? Difference of squares. All right. Now I'm going to do a little distributing. So 45x plus 45 times 3 is 135, plus 45x minus 135 equal to 8x squared minus 8 times 9 is 72. Okay, so let's see here. On the left-hand side, 135 minus 135, that goes away. 45 and 45 is 90x equal to 8x squared minus 72. All right. With a quadratic like that, I want to set it equal to 0. So I'm going to subtract 90x from both sides. All right, so I'll have 0 equal to 8x squared minus 90x minus 72. So, trying to get the greatest common factor out. I know I can pull a 2 out, right? So that'll leave 4x squared minus 45x minus 36. Okay, so this probably factors. You can always go to the quadratic formula. I want to see if I can factor it. It's a good challenge. So 4x squared minus 45x minus 36. We can use the AC method here. So 4 times 36 is 144, negative 144. Factors of negative 144 that add to negative 45. Okay, so I know 144 is divisible by 2, but that's going to be too big to get us to negative 45. I also know it's divisible by 3, right? Because if you add the digits, 1 plus 4 is 9. So 144 divided by 3 is 48, right? So factors of negative 144 that add to negative 45. So I would say negative 48 and 3. Okay, so if we rewrite the middle term, 4x squared minus 48x plus 3x minus 36 equal to 0, and then factor by grouping, right? So in the first group I can pull out a 4 and an x, and I'm left with x minus 12. And in the second group I can pull out a 3. I'm left with 3 times the quantity x minus 12. And now x minus 12 is common to both of those terms, right? So I'm going to have x minus 12 times 4x plus 3. Okay, so in my factoring over here, I'll complete the problem here. I've got 2 times the quantity x minus 12 times 4x plus 3. Okay, so I know that either x minus 12 is 0 or 4x plus 3 is 0. All right, so if I add 12 to both sides here, I'm going to have x equal to 12. And over here with a 4x plus 3 equal to 0, I can subtract 3 from both sides and then divide both sides by 4 for an answer of x equal to negative 3/4. Okay, so in terms of the speed of the boat in still water, it certainly doesn't make sense to have a negative answer, right? So I'm going to use the x equal to 12, and I'll put that in a complete sentence. So the speed of the boat in still water is 12 miles per hour. Okay, so just a word about this problem. The way I went about factoring that, sometimes when the numbers get complicated, if you want to go to the quadratic formula, that's okay too, because that'll work every time.